The one space photo that blew open the universe. You know that feeling when you think you understand something, and then one piece of evidence completely shatters your perception of reality. That's what happened to humanity in 1995. Take a grain of sand, hold it at arm's length toward the sky, point it at what looks like absolutely nothing, just darkness between the stars. Now imagine aiming the most powerful telescope ever built at that exact spot and staring for 10 straight days. What astronomers found in that tiny, boring patch of emptiness changed everything we thought we knew about the universe. I'm talking about thousands of galaxies, each containing hundreds of billions of stars, all hiding in a space smaller than a pinhead held at arm's length. This is the story of how one photograph proved we'd been vastly, almost embarrassingly wrong about how crowded the cosmos really is. The year was 1995, and the Hubble Space Telescope had a problem. Not a technical problem, but a PR problem. Hubble had been fixed after its infamous mirror defect and was producing stunning images. But some astronomers wanted to do something that sounded absolutely insane. They wanted to use Hubble's precious observation time that dozens of researchers were competing for, to photograph nothing. And not just photograph nothing quickly. They wanted to stare at nothing for 10 consecutive days. The proposal came from director Robert Williams, and it was controversial. Imagine telling the world's best-equipped observatory to ignore all the beautiful nebulae, nearby galaxies, and exotic stars, and instead point at a patch of sky in Ursa Major that appeared completely empty. No bright stars, no obvious galaxies, nothing that seemed interesting at all, just darkness. Many scientists thought it was a waste. Some called it a gamble. They had no idea they were about to witness one of the most important images in the history of astronomy. Between December 18th and December 28th, 1995, Hubble did exactly that. It locked onto this unremarkable spot and took 342 separate exposures, totaling about 100 hours of observation time. When astronomers combined these images into one deep exposure, what emerged from that darkness was breathtaking. Where there had appeared to be nothing, there were now about 3,000 galaxies. 3,000 galaxies in a patch of sky so small you could cover it with a grain of sand at arm's length. These weren't fuzzy blobs either. They were spirals, ellipticals, irregular galaxies in various stages of evolution and collision. Some appeared blue, indicating vigorous star formation. Others glowed red, ancient and evolved. And here's what made astronomers' jaws hit the floor. Most of these galaxies had never been seen before, because they were so incredibly distant that their light had been traveling through space for billions of years. This single image, now called the Hubble Deep Field, contained galaxies that existed when the universe was only a few billion years old, less than a quarter of its current age. Suddenly, that grain of sand at arm's length contained more galaxies than anyone had imagined possible, and each of those galaxies held hundreds of billions of stars of their own. But astronomers weren't satisfied. If 10 days of staring revealed 3,000 galaxies, what would happen if they stared even longer at an even darker patch? In 2003 and 2004, they got their answer. Hubble turned its gaze toward a tiny region in the constellation Fornax and observed for over 400 orbits, collecting data over a span of about 11 days. This time they were going deeper, pushing Hubble to its absolute limits. The result was the Hubble Ultra Deep Field, and it was even more mind-bending than the original. In a patch of sky that would fit behind a pinhead held at arm's length, this new image revealed approximately 10,000 galaxies. 10,000 galaxies. Stop and think about that for a moment. Every single one of those galaxies contains hundreds of billions of stars, and each of those stars could have planets. We're talking about trillions upon trillions of worlds, all compressed into what looks like nothing to the naked eye. And some of these galaxies were among the most distant objects ever observed at the time. Their light had been traveling for over 13 billion years, meaning we were seeing them as they appeared just 400 to 800 million years after the Big Bang itself. These were baby pictures of the universe. So what did all of this actually tell us about the cosmos? First, it confirmed what many scientists suspected but couldn't prove. The universe is unimaginably packed with galaxies. If you can find 10,000 galaxies in such a tiny patch and the sky has millions of similar patches, then simple math tells you we're living in a universe containing hundreds of billions of galaxies, possibly even 2 trillion galaxies by some estimates. Every direction you look, no matter how empty it appears, is teeming with island universes we simply can't see without powerful telescopes. Second, these images introduce the general public to the concept of look-back time. Because light travels at a finite speed of about 186,000 miles per second, when we look at distant objects, we're literally seeing them as they were in the past. A galaxy 10 billion light-years away appears to us as it was 10 billion years ago. The deep field images became time machines, showing us the universe's history laid out in a single photograph. The closest galaxies appear as they were a few billion years ago, while the faintest, most distant ones show us what galaxies looked like when the universe was still in its infancy, when the first generations of stars were just beginning to forge heavy elements, when the cosmic dark ages were only recently ending. Third, these images revealed that the early universe was far more chaotic than our relatively calm cosmic neighborhood today. Many of the distant galaxies in the deep fields appeared irregular, distorted, or in the process of merging with other galaxies. This gave astronomers direct visual evidence that galaxies grow and evolve over time, that the massive spiral and elliptical galaxies we see nearby, including our own Milky Way, were built up through countless mergers and interactions over billions of years. The deep fields weren't just pretty pictures. They were scientific gold mines that sparked thousands of research papers studying galaxy formation, the evolution of the universe, and the history of star formation across cosmic time. Then came James Webb. If Hubble revolutionized our view of the deep universe in visible light, the James Webb Space Telescope was designed to go even deeper by observing in infrared light. Why infrared? Because as the universe expands, the light from the most distant galaxies gets stretched by that expansion, shifting from visible wavelengths into the infrared. It's called cosmological redshift, and it means that the most ancient galaxies, the ones Hubble could barely detect or missed entirely, would shine brightly in Webb's infrared eyes. On July 11, 2022, the world got its first taste of Webb's power when NASA revealed Webb's first deep field image, SMACS 0723. President Biden himself unveiled it in a White House briefing, and what we saw was stunning. This image showed a cluster of galaxies in exquisite detail, but more importantly, scattered throughout the image were thousands of background galaxies, many of them appearing as smeared arcs and multiple images due to gravitational lensing, where the massive cluster's gravity bends and magnifies the light from even more distant galaxies behind it. Webb's deep field was described as the deepest, sharpest infrared image of the distant universe ever taken, and it represented just 12.5 hours of observation time. 12.5 hours. For comparison, the Hubble Ultra Deep Field took hundreds of hours. Webb was revealing the distant universe with unprecedented efficiency and clarity. As Webb continued observing and astronomers created deeper composites, we began seeing galaxies that existed just a few 100 million years after the Big Bang. Some estimates suggest Webb can detect galaxies forming as early as 200 to 300 million years after the universe began. These galaxies appear as they did over 13.4 billion years ago, giving us a view of the cosmic dawn when the first stars and galaxies were assembling from the primordial hydrogen and helium left over from the Big Bang. And here's the kicker. Many of these early galaxies are surprisingly mature, more massive and well-structured than theoretical models predicted. Webb is forcing us to rewrite our understanding of how quickly galaxies formed after the Big Bang. So what do astronomers actually do with these deep field images besides stare at them in wonder? These aren't just cosmic wallpapers, they're scientific instruments. Astronomers use spectroscopy to measure the redshift of individual galaxies, which tells them precisely how far away each galaxy is and when in cosmic history it existed. By studying thousands of galaxies at different distances and ages, they can piece together the story of how galaxies evolved over billions of years. They can track the history of star formation in the universe, measuring when stars were being born most rapidly and when that rate began to decline. They can study galaxy morphology, how the shapes and structures of galaxies changed over time, learning that early galaxies were often small, blue, and irregular, while modern galaxies tend to be larger, redder, and more organized into spirals and ellipticals. They can observe galaxy mergers in progress, watching as two galaxies collide and eventually combine into one, a process that our own Milky Way will undergo when it merges with Andromeda in about 4 billion years. The deep fields also help astronomers understand dark matter and dark energy. By studying how galaxies cluster together and how their light is bent by gravitational lensing, scientists can map the distribution of invisible dark matter that makes up about 27% of the universe's total mass energy content. And by measuring how the universe's expansion rate has changed over time using distant galaxies as markers, they can study dark energy, the mysterious force accelerating the universe's expansion, which accounts for about 68% of everything. Every galaxy in these deep images is a data point in humanity's quest to understand what the universe is made of and how it came to be. But beyond the science, there's something profoundly philosophical about the deep field images. They force us to confront our cosmic insignificance in a way that's simultaneously humbling and inspiring. Every time you look up at what appears to be empty darkness between the stars, you're probably staring toward unimaginable numbers of galaxies, each with hundreds of billions of stars, many of those stars likely surrounded by planets. The sheer scale of it all is almost incomprehensible. Our entire solar system is just one tiny speck orbiting one ordinary star in one spiral arm of one galaxy among trillions. And yet, as far as we know, we're the only place in all of that vastness where the universe has become conscious of itself, where matter has organized itself into beings capable of building telescopes and pondering our place in the cosmos. The deep field images are mirrors reflecting both our smallness and our significance. We're cosmically insignificant in scale, but we're the universe's way of knowing itself, and that's extraordinary. If this blows your mind, I've got news for you. It gets even better. Some of those distant galaxies Webb is observing contain planets, worlds orbiting alien stars in galaxies billions of light years away. And here's the incredible part. Webb isn't just photographing these distant worlds. It's already sniffing their atmospheres, detecting molecules and chemicals in the air around planets orbiting stars in our cosmic neighborhood. In Episode 6, we're going to explore how James Webb became a time machine that can taste the air on alien worlds, and what it's already finding might be the first hints of life beyond Earth. But first, we need to talk about something even more fundamental, the cosmic speed limit, and why it might make traveling to those alien worlds almost impossible. That's coming up next. If you want to understand just how vast and packed with possibilities our universe really is, hit that subscribe button and turn on notifications. Every week, we're diving deeper into the cosmos, and trust me, you don't want to miss what's coming. I'll see you in the next episode,